This is the high-purity reverse osmosis system. Commonly called the RO, it is a fully automated process with automatic controls and alarm system. An RO water system includes pre-filtration for particulate matter and chlorine reduction with carbon treatment. So, what is reverse osmosis? To best understand reverse osmosis, let's first look at normal osmosis. To illustrate, imagine a semi-permeable membrane with fresh water on one side and concentrated solution on the other, such as salt water. If normal osmosis takes place, the fresh water will pass through the membrane to dilute the concentrated solution. In reverse osmosis, pressure is exerted on the side with the concentrated solution to force the water molecules through the membrane to the freshwater side. This retains the salt to give us salt-free water. Particulate filtration at 5 microns is the first step in the treatment process. This filter ensures that all particulate matter is removed prior to the next step of filtration, as well as less long-term maintenance of the RO membranes. Reverse osmosis is sensitive to oxidizers such as chlorine, typically found in all city water sources. Therefore, the process and water RO water system includes granular activated carbon, commonly called GAC. The GAC is an absorbent and will reduce the levels of chlorine being sent to the RO membranes. The effluent of the carbon column passes through a higher micron capture filter to capture any carbon fines that may have been released from the vessel. The influent water has been pre-treated and is now prepared to be processed through the reverse osmosis membrane. As the water passes through the RO membrane, there is a low pressure switch to protect the pump against low inlet flow or pressure. There are panel-mounted pressure gauges to monitor the pre-treatment and reverse osmosis inlet and outlet pressures. The neighboring control panel is used to monitor water quality and facilitate operational functions. There are 3 streams that exit the reverse osmosis process. The permeate water, which is the clean, filtered, or product water, passes through the permeate flow meter and is sent to the product water storage tank. At higher salt levels, the concentrate is sent to sanitary sewer, or in some cases, non-critical locations for reuse, also known as gray water recycle. In higher water recovery applications, a small percentage of the concentrate water is sent back to the inlet of the RO membrane for recycle. The salt removal reverse osmosis step is complete, and the filtered water is stored for distribution and use. The product water is fed from the bottom of the tank to the distribution pump, where it will be post-treated before being fed to the facility points of use. The clean water low in salts, typically stored for a period of time, is a target for bacterial growth. Therefore, the process and water system includes a germicidal ultraviolet disinfection unit for bacteria control. Germicidal UVC light deactivates the DNA of bacteria, viruses, and other pathogens, and thus destroys their ability to multiply, which is critical in any process and lab use environment of RO product water. The UV-treated water is passed through a final filter, usually submicron, to filter any organic or non-organic matter from the subsequent ultraviolet treatment. In some cases, further ionic removal will be needed to meet the ionized water quality. If this is required, Process and Water implements a DI polishing bed containing strong acid cation and strong basic anion resins to remove all remaining ionic constituents in the water. The product water has been post-treated and is ready to be sent to the points of use.
Si Robin, ka na! Bayan mo ba? Hindi na! May tubig na lang sa taas! Kaya, So, bayan mo ba? Ano na? Bayan mo ba?
Ano, kailangan ba? Bakit tawa-tawa? Pagkilamos muna.
Magbigay. Ops! Meron ba yan? Meron yan. Meron ito eh. Umahon na ako. Meron ito sa mga tropa natin.
Action!
Tubig! Tubig? Robby! Paano yung tubig? Dali mo.
Kuha mo na, Robby.
Sa amin! Narmariten.
Kuha mo na. Saan ka magaling? Saan ka napagod ka?
Binuto sa akin si Sir, nagpaipot ako. Sabi niya, Sir, punta ka dito. Sabi mo pinunta ako, punta ka lang dito. Pinagsabi na ako na napakalahay.
Ilang niya yan, nakabali siyempre.
Yun nga eh. Hindi.
Wala ba? Ano ako, pinag-sopalis ka rin siya. Tama lang. Dahil may tubig kami, at tumaw na ako. Bibigyan kita natin ito. Alam mo ba? Ang tubig ay, ang tubig ay buhay. Alam mo ba?
Hindi ko alam yun.
Kasi, mas maganda ang tubig na yan. Ito sa mga nangyari ng mga iluwag sa mga ganyang tubig. O ibang talaga. Malinis na malinis. Di ba, Fred? Oo, tama yun.
Ano yung mga industry? Magaling yung mga ganun.
Pero ganyan ba? Kaya marami sa Pilipinas ang ano. Hindi ko napapansin maraming dialysis na naglipanan sa Pilipinas. Anong pangdahilan na nun? Simple lang, hindi sila madalas kulang ng tubig. Kaya, kasi ang katawan natin, 70% na ang katawan natin, tubig.
Pero bago yung pagbigat na sa pagbigat ng tubig, kailangan yung ligan sa dito. Kasi kung sa dito, maraming pwede ka pagkasabay. Teka, guys. Paano nga ba natin malalaman kung malinis ang isang tubig?
Ano nga ba?
Imagine an Earth without water, life without water. We find it everywhere, in the atmosphere and below our feet. 3/4 of the Earth's surface is covered by this essential liquid. It's a difficult thing to imagine life without water, because our own survival depends on it. In fact, water is vital to the existence of all forms of life on Earth. Water, or H2O, is an unusual compound with amazing properties. These unique properties are what make it so important to life. First of all, water happens to be the only substance on Earth that can be found naturally in all 3 states, as a solid, a liquid, and a gas. It is rare in that it actually expands as a solid, which is why ice can float. Pure water is essentially colorless, odorless, and tasteless. Water has a neutral pH, which means it is neither acidic nor basic. Water has been called a universal solvent because it can dissolve many substances. Wherever water goes, either through the atmosphere, the earth, or through our bodies, it takes along valuable chemicals, minerals, and nutrients. This is one reason why water accounts for about 70% of the weight of a cell, which is the building block of life. Water has high specific heat, which means it absorbs a lot of heat before it changes temperature. This is why water makes a great coolant. This is also why oceans, lakes, and water vapor in the atmosphere help to regulate the Earth's temperature. Water molecules are sticky. They attract to each other, which is why water tends to float together, fall as raindrops, and bead up on the surface of a leaf. This property is the result of cohesion. To understand cohesion, let's imagine we're recreating a water molecule. A water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. Because of the molecule's arrangement and the electronegativity difference between the hydrogen atoms and the oxygen atom, the molecule becomes polar. The oxygen atom has a negative charge, while the hydrogen atoms have a positive charge. Since we all know opposites attract, the oxygen atom will stick to a nearby hydrogen atom. The result is a strong bond. Surface tension is a result of cohesion and is the measure of how difficult it is to break the surface of a liquid. We can observe the high surface tension of water by watching this mosquito step onto its surface, or this insect as it struggles to free itself from a droplet. Surface tension is also what causes a water droplet to take a spherical shape. Water is the most cohesive of all non-metallic liquids. Adhesion is similar to cohesion, but refers to two different surfaces or molecules with an attraction to one another. This is why the droplet sticks to this leaf. Along with cohesion, adhesion is responsible for a phenomenon called capillary action. Capillary action is the force that pulls water upward against gravity through a narrow tube. This is an essential property for plants, which rely on capillary action to pull water from their roots up to their leaves. So it's pretty obvious that water is important stuff. Humans rely on it for personal consumption, as well as things like industry, energy production, and agriculture. But we sometimes have a tendency to use more than we need and pollute what's left. We need to make sure we keep it pure and plentiful.
Ganun pala pagproseso ng malinis na tubig.
Dyan. Ano, Robby? May natutunan ka ba?
Salamat sa inyo, natutunan ko yung tungkol sa tubig na yan. Nagbuo ko lang sa sobrang, malamang ano, nag-radish na ako.
Hindi lalo, baka ngayon. Huwag ka masakit ka sa bato.
May sasabihin ko sa classmates natin.
Sana sa mga classmates natin na dito, sana everyday, kung hindi man lang everyday, makainom sila ng walong baso ng tubig. Para, mahigit. Para makahigit sila ng tubig.
Saka pangalagaan natin yung tubig natin. Kasi, siyempre, ano yun eh, kumbaga sa atin eh,
Kung walang tubig, walang buhay.
saka yung mali sa tubig ngayon, mali sa tubig ngayon, hindi na madali makita. Saka binabayaran naman natin yung mga mahal sa tulad yung pagdala sa bote na yung presyo na agad dyan. Hindi na tulad ng mga araw, kung takalan ko sa bati, nakakita na naman sa tubig. Ngayon hindi na. Kailangan ko pumunta sa mga filling station, tapos sa mga proseso para
Now you know, big water.
Hindi big water, sami!
Never friend. May nasabi na natin yung set.
Sir!
ano ba yung hindi ako, dahil ako nahulog.
Salamat yan!